Hello everyone. Let's discuss about recursive functions. Recursion is a process of repeating something in a self-similar way. It is like a mirror facing another mirror. You will see a mirror in a mirror in a mirror in a and so on. It is similar when a live TV show is showing people watching the same live TV show in the TV. You will see a TV show inside the same TV show and so on. It also applies in C programming. The function that calls itself is called a recursive function, and this function call is called a recursive call. So there's too much call. Okay? Are you confused with repeating words like call, function, and recursive? Then let's see the syntax. Still the same with the function, but the body is different because it has two statements. First is the basis statement, and second one is the part where the function calls itself is called a recursive call. This function calls itself. Maybe it is lonely. Do you want to join him or this function? Let's join and know the two parts of the recursive function. There are the basis and the recursive part. The basis part is a conditional statement that stops the recursion. Without this, we will experience forever again. The recursive part is where you call the recursive function itself, or where the recursive call happens. This function is usually used on a recurrence relation or a sequence that uses its previous values, like a sub n is equal to a sub n minus 1 plus 1, where a sub 0 is equal to 1. Another example, a sub n is equal to a sub n minus 1 minus a sub n minus 2, where a sub 1 is 2 and a sub 2 is 1. The third example is a sub nm is equal to a sub n minus 1m plus a sub n m minus 1, where a sub n0 is 1 and a sub 0m is 2. In this relation, you will notice that a is using itself. You also see that the value of the first few elements. So, how can we create a recursive function out of this? It's easy. The elements with value are the basis part, and the relation that uses its previous value is the recursive part. So, the recursive function for the first relation is int first, then open close parenthesis, int n, and so on. What can you notice? None? Well, let's try to see the similarity, and let's look at the basis part first. What is n? Why is it compared to 0? Why do we need to return 1? How could it be related to a sub 0 is equal to 1? Oh, there's a 0 and a 1, but no n. it is compared to 0 because the subscript is 0. It returns 1 because its value is 1. Now, I see. Can you see? What about n? Oh, it's the subscript of the relation. Okay, we're done with the basis part. Let's check the recursive part. What can you notice? What is first? How is it related to the relation? And why n minus 1 is the parameter? And why you need to add 1? Are you confused with my questions? Look closer and compare the similarity. Oh, n minus 1 is the subscript of a in the right hand side of the equal symbol. Then does it means the first is related to a? Then how about the plus 1? Oh, there's also a plus 1 in the relation. Do you have any question? How about the type of the function? Well, the initial value is an integer, so we can assume that it is an integer. You can also use a float or a double if you want. If you ask me about the if statement and the return command, they are not optional. They must be there. They are not like trash that you will throw if you don't need it anymore. Now let's try the second example. Are you confident that you can make a recursive function out of this? Let's see. So this is the recursive function for the second one. Is your recursive function, if any, correct? Maybe you will ask why is it else if not else. You might ask why the else have semicolon and has no open and close curly braces. It is an else if and not an else because else mean not equal to, but we need n equals 1. So, keep it in mind that the basis doesn't need an else. If it doesn't need an else, then why there's an else? Because else will be mad if we will throw it. So we include an else that does nothing. That's why it has a semicolon, which also answers the second question. Though we can simplify the second relation or recursive function to this example. Let's check if this is also correct. If n is 1, then it will return 3 minus n, or 3 minus 1, which means 2. So it's correct. On the other hand, if n is 2, then it will return 3 minus 2, which is 1, and it is also correct. Though it has a better documentation or it has an optimized code, it is confusing. So it is alright for you to do the first one. Now let's go to the third one, the third relation, and this is the hardest among the three. So this is the code for this. There are two parameters because there are two subscripts, the n and the m. There's no condition of n on the if statement because a sub n0 does not specify the value of n. The same with the else if statement. Okay, there's no m. If you have more questions, you can always ask me. Okay? So let's go to An iterative function. So a recursive function also have an iterative or looping counterpart, though more parameters means complicated loops. So we will make examples for the first and second relations only. Before the explanation of the first relation, let me tell you a difference of recursive and iterative. The recursive is from end to start, while the iterative is from start to end. In the first relation, the recursive starts from n to 0 since the a0 has an initial value. Therefore, our iterative must start from 1 to n. So the subscript here is I, and the basis part is the initialization a is equal to 1. Of course, the recursive part is the a plus equals 1, which also means a is equal to a plus 1. The difference will be that a has no subscript. Let's try the second relation. This time we need two variables because there are two initial values. So our iteration is this one. So the initialization or basis is still the same. The iteration will start from 3 to n because a sub 1 and a sub 2 has also already the initial value. The recursive part is different because the goal here is to move the new value to a2 and the value of a2 to a1. But why do we need a new or a temporary storage? Why not assign directly? Okay, so to know the difference, let's compare the two. For example, a sub 1 is equal to 2 and a sub 2 is equal to 3. So the result should be a sub 1 will be now 3 and a sub 2 will be 5. Okay? Okay, so in the code, new is equal to a sub 2 plus a sub 1. The result therefore new is 5. While in the code where a sub 1 is equal to a sub 2, the value of a sub 1 there will be 3. Then in the next line of the code of the first example, a sub 1 is equal to a sub 2. So a sub 1 is 3. And then in another example, a sub 2 is equal to a sub 2 plus a sub 1. Because the value of a sub 1 is already 3 and not 2, that's why the sum of these two is 6 and not 5. But if we have a new, so the a sub 2 is equal to new, the value of a sub 2 is still 5. Okay? So the first code shows a correct result while the second is incorrect. This is the reason why we need a temporary storage. So you only need one temporary storage even there are more than two initial values. For this type of relation, the iterative is faster because the recursive Fibonacci is calling itself twice. To understand what I mean, let's take a look of this example. The one you can see on the left is a recursive function that calls itself twice. The other one is an iterative function. Both of them have the same value of n, which is 4, but the recursive has 13, while the iterative has 5 boxes. Therefore, the iterative is better than the recursive that calls itself twice or more. There's also an iterative form for the third relation, but array is needed. So the second relation is also easier to do with arrays. Though we haven't touched it yet, let's end our lesson here, but I will leave you an assignment number 7. Just hang in there. We finished the first half, so we can do the next half or the final half. Thank you and good luck.